Now we got angle problems, you bet. Here we go, got a UFO. Captures Jolene. Taking her back to Mars. We all knew that going in. Jolene's parents are standing 25 meters away waving by with a big smile on their face. I'm just kidding. Barb's crying next. So, the UFO is rising at a rate of 15 meters per second. What is the rate of change of the angle of elevation? Uh-oh, that's something new. It's an angle problem. When the UFO is 10 meters off the ground, that's what they want to know, the rate. Draw your picture if you don't have one. Here's the ground. The UFO is going up in the air. That's that 15 meters per second, right? Usually what do we call this letter? The Y. And so that could be my dy dt. Barb and Joel are over here. How far away? 25 meters. They are looking directly at Jolene and waving bye-bye. And the angle of elevation is there. From the ground to the line of sight. And so we want to find, it says, when y is 10 meters, we want to find d theta dt. Yes?
Okay. I am having trouble placing where the angle is. Like, how do you know it's a map when you're not getting
Angle of elevation is measured from
the bottom?
up. That one we had with the ladder, kind of, or the telescope yesterday, just kind of said from the angle from the cliff to the telescope. So usually everything we measure is going to be from the horizontal, but not always. Then when you're going to try and find the theta dt's, you got thetas. Right triangle trig is usually the only thing you got. So if I look at this, and I have my theta, that's my adjacent, and that's my opposite. SOH, CAH, TOA. Huh? What? It is. So the tangent of theta is y over 25. Simple looking equation, and it really is when you got angles usually. So now I got to differentiate. Secant squared theta d theta dt. And here's the derivative. You guys all got confused. It's just like the 1/25 is along for the ride, and the derivative of y is just 1. Question? Answer? Now the next hardest part. We got to find the secant of theta when y equals 10. So if I look specifically here at the triangle, the secant is hypotenuse over adjacent. I know the adjacent, I have to find the h. This is where it gets a little interesting. But 25 squared plus 100 squared, or 10 squared, excuse me, is 100. 625 and 100?
Why are we using secant instead of tangent?
Because I need the secant to plug it in.
Oh, okay.
Yep. And so that's the square root of 725. And I'm going to leave it like that for now because it's just going to go away eventually anyway. So the secant, when I go plug it in here, is the square root of 725 all over 25 squared. Use the Pythagorean theorem to get the hypotenuse. D theta dt 1/25 and 15. Now it's time to dazzle you with some math, I guess. If I square this, that's just 725 over 625, right? D theta dt. 15 and 5 is really?
Do I have to take the secant of that though?
No, that is the secant.
Oh, yeah.
The secant is
Yeah, I got it.
that whole thing. So I never really find the angle. I'm just finding the sides. Huh?
Why is square root of 725 over 25?
Why is that?
Yeah.
The hypotenuse is the square root of 725. See, the adjacent is 25. Then if I do some switch in a room, this is 625, that's 725. Lots of different things could happen here. I'm going to do the math on the calculator. I'm not in the mood. Probably 275 and something, but
Why are you just multiplying by that?
what do you else want to do?
Yeah. Why can you just do that?
Do what?
Multiply by the reciprocal.
I divided both sides, really. I'm just multiplying both sides by the reciprocal. So, I'm going to do that. It's like 5x.
It's 0.517.
0.517?
Yeah.
What is that?
And that's in radians per second.